Hello, this is Nas from NB Network Lessons. Welcome. Today's topic of discussion is solving another problem which involves directional derivative. So on the board, I have already written a function. In interest of time, function of xy is equal to tangent of x plus 2y. And at the points where we have to find the directional derivative are 0 and pi over 6. 0 is x, pi over 6 is y. Now, this is the vector given. A is equal to minus 4i. This is the x component, and this is the y component. What do? First thing you have to verify is that if it is a unit vector. So how do we do that? What we do is that, first of all, we find the length of the unit vector. Okay? And I showed you last time for 2 bars to represent that. And then you have a dash on top of it is equal to, what you do is you take 4, which is the weight, minus 4 square plus 5 square, which is the weight of the x component, and you under root all of that. And when you do that, you get under root of 41. So clearly, it is not a unit vector, because if it was a unit vector, I would have gotten 1 over here. So we, in this particular, with under root 41, we cannot find directional derivative. We have to do some manipulation. We have to do some math to make this vector a unit vector. Let's see how. What we do is that we take this vector and we take the vector which is a given right here, okay, and we divide it by the length of the vector. This is very important for you to remember. Okay, so now when I do that, I take minus 4i plus 5j. Okay, basically what I'm doing is I'm just writing this right here, divided by the length of the vector which we just calculated, under root of 41. Okay, no questions about it. So next, what we do is that we kind of simplify that, and we say minus 4i divided by under root of 41 plus 5j under root of 41. All I'm doing is that separating this 4 over under root 41 and then 5 over under root 41. Okay? So now this part right here is A1, the component, the weight of x. And this part right here is A2, which is the weight of the component of y. Okay? Now, what we do is that we find the partial derivative of this function with respect to x and y and apply our formula. So dA is the direction of the vector of function, okay, 0, pi over 6, okay, is equal to function with respect to x. Find function of with respect to x. So when you do that, what is the derivative of tan? Derivative of tan is secant square. So then what we have is equal to secant square x plus 2y, okay, x plus 2y. Now you're taking derivative with respect to x right here, a function of x. Okay, so then if you're taking the derivative with respect to x, then what would you, this would be just a constant. So it would be just 0. So you're basically applying the chain rule and finding the derivative of inside. So it will be just 1. Why? This, we're taking derivative with respect to x. When you take derivative with respect to x, you treat this 2y as constant. And then derivative of x is just 1. Okay? Plus, you take derivative with respect to y. Let me do it separately right here. Fy. Now, it's going to be secant square again. Okay? Into x plus 2y. Now, what would I multiply that? What's the derivative of inside? I'm taking derivative with respect to y. Okay? So if I'm taking derivative with respect to y, this right here, x is constant. The derivative of that is 0. Derivative of 2y is 2. There you go. All right. Now, let me just move this a little bit over here so I can get more room. So then what I do is that I say d of f, directional derivative, f at 0, pi over 6 is equal to 1 over, what I'm doing is that, remember I showed you the table last time, you can find the reciprocal or inverse. So the inverse of secant square is, it's basically cosine. So I'm going to use that because it's easier to play with cosine. You can find values in radians and degrees in with cosine easily. So just a tip. Cosine square x plus 2y. Okay. All right. X plus 2y. And then what we have is that for, let me do this. Let me write this again. Okay. So let me take the inverse of this first. So f of x is equal to, for this right here, I'm doing inverse, 1 over cosine square x plus 2y. And then for f of y is equal to 1 over cosine square, this is 2 over x plus 2y. Okay? So basically all I'm doing is I'm taking reciprocal of this, like I showed you in the chart I drew last time. So now what we have to do is we have to find the derivative of this at point 0 and pi over 6 is equal to, now pay attention, stick with me, cosine square, I'm plugging in these values 0 and pi over 6 into x and y. Okay, so 0 plus 2 into pi over 6. Okay, you got to multiply that with a1. What was the value of a1? Boom, right here, minus 4 over under root 41 plus, you got to find derivative of this right here, fy. So what I do is that I say 1 over cosine square, okay? This is actually 2 cosine square 0 plus 2 pi over 6. What will this be multiplied by? Y component. What is the y component? This right here. Just circle that. This is the x component, a1. This is the y component. So I'm going to multiply that by 5 over under root 41. Why don't I draw just a big bracket over here? And then once you simplify that, which I'm sure you guys are capable of doing it, but I don't have time to do all the steps, you will get 24 over under root 41. So this is, my friends, the derivative or the slope at these 2 points right here, 0 and pi over 6. Watch this video a few times, it'll make sense. If you love calculus, stick with me. I love calculus and I like to share knowledge also. So stick with me and hopefully we both will learn and become good. Thank you. Have a good day.